Module 9, cooling infrastructure. So this is a bit comprehensive, chapter with respect to cooling, and let's see what we are going to discuss and learn in this chapter. After completing this chapter, what we would cover the trend in the heat load and the problem it poses to the mission critical side. We discussed yesterday, because more and more equipment is coming in high density, small footprint, more heat load, and more cooling required. So this is a challenge these days because high density compute, network, storage, all are coming in. The various air conditioning types with its pros and cons. We will talk about different kind of air conditioners, like two major different types, like comfort air conditioners and precision air conditioners that we use in data centers. And then we will talk about the different options available for the precision cooling for data centers. We will also talk about different cooling units. This is the chapter which, Bashar, you were asking. Raised floor and non-raised floor cooling. So if you have a raised floor and non-raised floor, how to set up the rack placement and equipment placement and the air conditioning placement. So all these things we will talk about in both the scenarios. If you have a raised floor and if you don't have a raised floor. So we have two sections covering this in reasonable detail about the setup. Various techniques that can be used for high density cooling requirements. So we also call it in this session supplemental cooling. So if you have a standard cooling for your data center, whether with raised floor or without raised floor, but you need some additional requirement for a few racks where you have a high density requirement which you originally did not plan how to handle those situations. Okay, so there are quite a few options that we will discuss for techniques for high density cooling requirements or supplemental cooling. Cold and hot aisle containment. This is also very common to contain the aisles, whether hot aisle or cold aisle, to improve the efficiency. So we will discuss how it can be done, what are the risks, for the containment, which containment is better in which situation, like hot or cold. So we'll all discuss it in the hot and cold aisle containment. And the last topic today for the cooling chapter is seasonal thermal energy storage. Because as we said, more and more people are more concerned about the environment and the energy efficiency and all this. So seasonal thermal energy storage we will also discuss. So I would give you a flashback of yesterday where we discussed the causes of downtime. So we discussed two major causes. One, human error. Number two, hardware and system failure. In the hardware and system failure, we discussed power quality, which we discussed in quite detail yesterday, electromagnetic field, and we also discussed environmental effects. So if you see, as per the international research, the equipment which fails in the data center, 55% of the equipment fails because of the high temperature. Okay. 20% is vibration. 19% is humidity and then contamination and dust is 6%. So we should be careful about environment, like right amount of airflow, temperature, humidity, no vibration. We discussed yesterday, creating a gap with the raised floor and to protect from the vibration and all. So here is a snapshot of a typical power consumption in data center. So if you can see, if our IT equipment is consuming around 52% power, so 48% is going elsewhere, like in cooling, light, HVAC fans, PDUs, UPS and all. Okay, so to produce basically, you can say a 1 megawatt of IT services, you need 1 megawatt of cooling and other requirements to provide this, those IT services. So it's almost 1-to-1 ratio, almost 50%. So the whole industry is working to make more and more efficient IT systems, more and more efficient cooling systems to reduce this effect and improve the efficiency. ASHRAE is the American Society of Heating Refrigeration, so it is a global standard. So as I said, we discussed yesterday standards for the subcomponents. So every component, like for the fire systems, for power, electrical systems, and similarly for HVAC, we have a global standard ASHRAE guidelines, and they have a committee within ASHRAE. TC 9.9 is called Technical Committee 9.9, which sets the guidelines for the allowable environmental parameters for the data center, because they work very closely with EIA, Electronic Industry Association. So if you know the TIA 942, the full name is TIA EIA 942. So Telecom Industry Association, Electronic Industry Association, and then 942. So the current recommended values for equipment inlets in the data center, remember this point where we need to maintain what is the range of temperature, is 18 to 27 degrees centigrades. So we should maintain the temperature between 18 to 27 as per the ASHRAE guidelines for the data center. Okay. So yeah. Sorry? Hyperscales? Yeah, actually, this was a typical, energy. It's a long subject, because people are choosing locations where they can use free cooling, environment, going to build data center in a climate where most of the days of the year, they don't have to run, condensers for the cooling, and take the free cooling system. Yeah, that's right. So there are a lot of systems these days that comes. The chiller systems come with the hybrid, including the. So even if out of 365 days, say 50 days or 100 days, you get a temperature which is below. Yeah, exactly. So you can take these into and take free cooling advantage. Okay. So what is delta T? The people who, so many people would be aware, but the delta T is called the difference between the temperature of the cold aisle and the hot aisle. The difference in the temperature. So you can see here, if we are giving server inlet 20 degree temperature, 20 degree is going into the equipment it passes through the equipment, and here you can see the temperature that could be say 35. So the difference of these two is called delta T. Okay, in the high density compute, this delta T is increasing. Like normal, typically it is around 9 to 11, 12 degree, centigrade delta T. But in the high density compute, it is even increasing to 15, 18 degrees centigrades. So what Bashir, you talk about the humidity. To understand the humidity, you also need to understand the dew point. Dew point is also very important to understand. That when first you need to understand what is the definition of dew point. So the dew point is when at certain temperature, air is not able to handle the moisture. Okay, and the classic example is if you take this bottle of water, put it in the refrigerator, chill it, take it out, put it here. After some time, you will see the water outside. Where the water comes from? Outside the bottle. It comes from the air, because at very low temperature at the surface of the bottle, air is not able to handle the moisture. So you need to know the dew point of your data center. The typical range of the humidity is around 45 to 80%. Recommended is to keep it around 55%. But understanding the dew point is important. So how do you know what is the dew point for your data center? Okay. So there is a typical formula for the dew point, if you people know, the formula is dew point is equal to temperature in centigrades minus 100 minus relative humidity percentage divided by 5. This is the formula for dew point. Okay, and to make things easy for you,